My name is Gerard Stroomberg. I'm a director at Riva Rijn. It's the Association of Drinking Water Companies that are dependent on the River Rhine. And I'm presenting the results from the project where we looked at monitoring data for a clean Rhine-IJssel water quality. So just to give some context, in the Netherlands, over 5 million people are dependent on the River Rhine as a source for their drinking water. And as you can imagine, we have a particular interest in anything that influences the water quality of the River Rhine. And particularly, as you can see here from this map, if we look at the region in North Rhine-Westphalia, it's heavily influenced by industrial emissions, and of course, there's also major population centers as well. And even if we zoom in and we look at more detail, this is a map from the North Westphalian authorities showing all the point sources for industrial emissions, either directly or indirectly into the sewage system. So, but its system, it's called ELWAS. It also presents the data for all these individual emission points. And so we are able to collect the data from this website. But we do this by downloading individual Excel sheets. So you can imagine that doing a meaningful data analysis on all these sheets is near impossible. So for this, we really need a good workflow that allows us to extract the data and then also do our data analysis. So in that sense, we were very happy to collaborate with the WATERVERSE project because it allowed us to actually do this type of analysis and actually do it also in a multi-regional setting. For instance, the data analyst was working from Düsseldorf, and while we ourselves are based in the Netherlands. So what we learned from this project is that we have now an automated data pipeline that allows us to collect the data from North Rhine-Westphalian databases and transform them into a format that allows us to do a meaningful data analysis, to do it in a standardized way and harmonized, so that we can actually not just do it once, but we can do this repeatedly into the future. We now have an advanced analytics pathway where we can actually collect the data, evaluate it, and find the point sources that are of most interest for us. And then also use that information to propose meaningful measures to protect the river water quality as for our production of drinking water. And all in all, it gave us great benefits in efficiencies. You can imagine that going through all these Excel sheets one by one, it takes forever. But with this pipeline, we now are able to do this in a very meaningful way, in a repetitive way, with a high degree of confidence in the results. So in that sense, it was really a very good proof of concept. But we're also looking forward into expanding this into the future and improving our knowledge of the water quality of the river and the potential influences that are there upstream. So the benefits that we see from using WATERVERSE are, of course, first of all, the results that yield environmental benefits. With this improved data management, we have been able to make more informed decision making for protecting our river water as a source for drinking water. And of course, you can imagine drinking water, it has a high societal impact, but not just for in protecting our drinking water source, but also showing doing this in a collaborative way and showing to other stakeholders what this means, what we can to do it also in a transparent way, where others can follow along our steps that we take in analyzing the data. It shows the interoperability. We now have a seamless data flow, which with previously incompatible systems where we had to do a lot of handiwork, which we can now automate, and that also gives us a high degree of efficiency. things that would take us days, we can now do in hours, and maybe in the future even in minutes. So we look forward to using the system into the future.
The data contained in the various Excel files is uploaded to the data portal through the data connector. This step makes it possible to centralize all information in a single environment, ready for subsequent preparation and analysis operations. By clicking on Browse, you select the Excel files one at a time that you want to upload to the data portal. Once all Excel files have been selected, click Run to perform the upload. The data portal will respond with the details of the completed operation. The data is uploaded to the data portal under the WATERVERSE organization in the Environmental Discharge Events Monitoring dataset within the raw Excel data resource. To harmonize and analyze the data uploaded to the data portal, a mashup will be built inside the data preparation pipeline editor, composed of several operators. The first operator is the WDME data portal. This operator retrieves the data previously uploaded to the data portal, representing the starting point of the analysis process. To retrieve the data, it is necessary to enter the resource ID, found in the detailed information, indicate which fields we want to retrieve, in this case, all of them, and enter the API key to authenticate the mashup and access the data. The operator displays a preview of the retrieved data and the associated resource ID, which is the one previously entered. The second operator is the FIWARE data converter. This operator harmonizes the data by transforming it into a smart data model compliant with the standard and with NGSI LD. To use this operator, you must copy and paste the output of the WDME data portal operator into the input of the FIWARE data converter. In this case as well, the mashup shows us the operator's output, demonstrating that the data has been correctly harmonized. The third operator is RHINE analysis. This operator analyzes the already standardized discharge dataset with the goal of identifying anomalies or particularly significant discharge events. The analytical process begins by importing the output of the FIWARE data converter. The operator calculates a series of statistical thresholds based on the mean and standard deviation, creating different sensitivity levels. 0.5, 1, 1.5, and 2 times sigma. Each threshold represents a different degree of sensitivity in identifying anomalous values. In this output, you can see that the CSV files for each sigma, as well as a summary file, have been created and uploaded to the data portal with their respective URLs. Finally, the RHINE visualization operator is used. This operator takes the analysis results and converts them into structured CSV files ready to be used for creating external visualizations or reports, starting from the CSV files generated by the analysis operator. The RHINE visualization operator confirms that the data has been successfully uploaded to the data portal. In the data portal, within the RHINE visualization dataset, it is now possible to view the CSV files generated by the operator, and by clicking Download, you can download these CSV files for consultation. The CSV files generated by the RHINE visualization operator and currently available on the data portal can be imported into DashRAM through the Data Import from CSV Service section. In this section, you need to enter the link to the CSV resource in the CSV address field. Once the data is uploaded, you click on Preview to check that the data is correctly formatted. Then you configure the database where you want to save this data, for example, a PostgreSQL database, and a table name such as Sigma 5 data. It is possible to choose what to do with the table at each new job execution, error, append, or replace. After the job is created, to view it, you click on the Settings menu under Jobs. Here, you can see the list of all created jobs. To run a specific job, simply click the button with the lightning icon in the last column, Execute Job. When the job is executed, Dashram creates a dataset inside the selected database using the previously configured table name. By clicking on the dataset, it is possible to create charts with the newly imported data. In this case, a tabular visualization is being used to display all the columns of the dataset. To create a new chart starting from our dataset, you click on the Chart section. Dashram will display the list of all available chart types. To create a new chart, you select the dataset and search for the chart type required for the visualization, for example, a heat map. Once the dataset and chart type are selected, you click on Create New Chart. Here, you can configure all the fields required by the chart. To save this chart and display it on a dashboard, simply click the Save button at the top right. You then enter the name of the new dashboard you want to create. You can either save the chart inside the dashboard and continue working, or save the chart and immediately display the newly created dashboard. Each dashboard can be edited using the Edit Dashboard button. This feature allows you to visually modify the chart settings, such as dimensions, or add new charts to the dashboard. In this case, the previously created heat map chart has been successfully saved inside the dashboard. Here is the final dashboard, enriched with several visual elements: heat map, time series, pay chart, interactive table. All these components are fully dynamic, allowing the user to explore the data in a simple and intuitive way.